Hi, so today we'll be looking at this physics problem, and the question says that we are given an object with a mass of 5 kilograms, and it's being pushed up an inclined plane with a constant force F. The plane makes an angle of 30 degrees with respect to the horizontal, and the object is moving with constant velocity. The coefficient of kinetic friction between the object and the surface is 0.3, and we are asked to find the magnitude of this force. So first of all, we'll write our constants. So we know the mass is 5 kilograms, coefficient of kinetic friction is 0.3, and the angle is 30 degrees. So first we'll start with drawing our free body diagram. We know that we have our applied force, our gravitational force, our normal force, and our frictional force. So we should add in our coordinate axis. And we can also break up FG into its y and x components. So we'll have FGY and FGX. And then we also know the angle is 30 degrees. So first of all, we'll write down what equations we'll be using today. So we know that Fg equals mg and Ff equals the kinetic friction coefficient times the normal force. So first we'll do sum of forces in y, and we know this equals to 0 because the acceleration of the block is 0 in the y direction. So by looking at our free body diagram, we know that the forces in the y direction are Fn, which is positive y direction, and Fgy, which is in the negative direction. So we can rewrite this as Fn equals Fgy, and we also know that Fgy equals Fg cosine 30 by looking at our free body diagram. So we already have the equation for Fg, so we can just plug that in. So 5 kilograms times 9.81 meters second squared, and then multiplied by cosine 30. And so doing this, we will get the answer of 42.5 newtons. So now that we sum the forces in the y, we can sum the forces in x. So we also know that because the object is moving with constant velocity, which we were given in the question, that there is no acceleration of the block in the x direction, so we can set that equal to 0. So now looking at our free body diagram, we see we have the applied force in the positive x direction, we have the force of friction in the negative x direction, and then we also have Fgx in the negative x direction. So this can be rewritten as the applied force equals the force of friction plus the gravitational force in the x direction. And so looking at our equation above, we know the force of friction equals the coefficient of kinetic friction times the normal force, and then we know that Fgx equals the gravitational force times sine 30. So then subbing this in, we get 0.3 times 42.5 newtons plus 5 kilograms times 9.81 meters over second squared times sine 30. So then when we solve this, we end up with the answer of applied force is equal to 37.3 newtons. And that is your answer, and I hope this helped.